Alright, another question. So this question is about linked list cycle. Basically detecting a cycle, that is whether a linked list is having a loop that is being formed in it or not. So that means if the tail of the linked list is having a next, that is something inside of a linked list, so that makes it a cycle or a loop. So yeah, how do we do that? How do we approach the question? Let's have a read first for it, although it's pretty simple, but still. A given head, uh, the head of a linked list determines if the linked list has cycle in it. Uh, there is a cycle in a linked list if there is some node that in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node. So yeah, this thing is used internally. It has no relevance inside of this code. So POS is 1, so yeah, it's gonna come back at 1. Note that POS is not passed as a parameter, so yeah, return the true if there's a cycle and otherwise it's false. So how do we do or approach this question? So for this question, the thing that has to be taken in consideration is uh, the fast and slow pointer method. So what's with that is the fast and slow pointer method. So fast and slow pointer method is a method that tells us that if there is a cycle or not. How it works is the basic functioning of that fast and slow pointer is that suppose there's a racetrack. It's circle. Yeah, there's a circular racetrack. What happens is two people start at the same point. All right, they start at the same point. Uh, the first person, suppose the racetrack is of, for example, um, 12 kilometers. Yeah, the first person moves ahead by 2 kilometers. The other person moves ahead by 4 kilometers. Fast and slow pointer, the fast one is going to be moving twice the speed as of slow. The first person moves ahead by 2 kilometers, the fast person moves ahead by 4 kilometers. Other person is at 6, the fast one is at 8, other one is at 7, the other one is at 10. The point is, these people are gonna keep moving, but there will be one point wherein they will be meeting again. Because, of course, the fast person is gonna catch up sooner or later with the person who is moving slow. Reason being, the person is moving twice the speed of the slow person. If there is a circle, they both start at the same point. If the slow person is still here, the fast person will be right here. When the slow person from here gets here, the fast person from here will be getting here. When the slow person is gonna get here, the fast person from here will be like right here. When the slow person is gonna get here, the fast person is gonna catch up. So the thing is, if this thing happens, it's gonna be a cycle. If this thing doesn't happen, it's not gonna be a cycle. Because yeah, if a fast person is able to catch the slow person, then it means there is a cycle, of course. So that's the basic understanding of the question, because if it was not a cycle, if it was a linked list, like going in the straight direction, there is no way possible that the fast person is gonna catch slow pointer. The fast pointer is gonna move ahead, keep moving ahead, so the slow pointer is gonna keep moving ahead as well. So yeah, in order for the fast pointer to catch the slow pointer, there has to be a cycle. So if it catches the slow pointer, cool, we have a cycle. If it doesn't, we don't have a cycle. So yeah, that's the basic approach for the question, and let's start to implement it. So the basic understanding is they both start at the head. Yeah, they both start at the head, while fast is not equal to slow. Wait, while it's not equal to slow, do one thing. Fast equals fast dot next. Yeah, fast equals fast dot next, and slow equals, wait, it's gonna move twice the speed, so next dot next equals slow dot next. Cool. So slow is gonna move 1, fast is gonna move 2. Simple. So if fast, slow, yeah, wait, I don't think we need a if thing. Yeah, all we need is return false. If fast is not equal to slow, keep moving ahead. The moment fast becomes slow, loop ends, I return true. Yeah, makes sense. I return true. Cool. Yeah. Let's keep a check for this thing as well. Yeah. If head dot next equals null, return false. Let's see if it works. Oh, it works, right? So null pointer. Oh, all right. Let's have another thing. If head equals null, return what it needs is. Wait, what do you need? Wait a second. Position false, if that's what you need. Because there is no cycle. Cool. Wrong answer for 1 and 2. -1, which output true, expected false. What? It's saying that 1 comma 2, that is, yeah, POS is -1, so that means it's getting back at that index doesn't exist, but cool, understood. Is there a cycle with the tail connects to the first node 0 index? So how can that be -1? Like, tail is connecting to something that doesn't exist. I'm countering the head thing. If head is null, I'm saying if head dot next is null. I need a check wherein it's like, if this thing doesn't work, it's true. If this thing doesn't work, it's true. Like, yeah. The fast, till the moment fast is not equal to slow, you know, return true, and till the time fast is not equal to slow, keep moving them ahead, you know, keep doing that. The moment they become equal, that's the thing wherein we know that the thing has a cycle. So return true. Alright, I return true for that. Cool. Then what has to be taken care of? If they are not equal, so yeah, how do we tackle that? Because position has nothing to do with the parameter passed right here, so I'm kind of confused with this test case, like how can it be -1? Because obviously, why is it taking me, you know, back at something that is not existing? Index -1, basically, something before 0. And I'm saying that if head dot next is null, return false. Should I be saying how about now? Makes no sense, although. Wait, why does it make sense? Alright, head dot next is null, so it makes sense. But will it work? Yeah, because obviously there is, yeah. It has to give false. It has to give false somewhere, which I'm not letting it give. I'm saying if they are equal, return true. I'll need to have something else situation. So let's do one thing. You know, let's say after the while loop ends, if fast equals slow, return true, else false. How about now? How about with this test case as well? If I run, oops, wrong answer. Position -1. There is head is this, so it's not gonna go back. Output true, cycle does exist. What? How? How can cycle exist at something? Wait, output is coming out to be true. How is it coming out to be true? Wait. What if I do this? Cool. Yeah. I guess a lot of edge cases, or maybe I'm just having a logic wrong in my opinion. So this thing is like, alright, the head is like, if they are saying head 3, so this is the head, this is the thing, so cool. Position 1, so up at 4, that is at the 5, it's coming back at -1. Like it was coming at 4, So here first position is gonna come at null. I'm giving output as true. How? Why am I giving the output as true for this? Why is that? Okay. Understood. Yeah. It's coming out to be like true when it's like, alright, 5's next is something that is null. Oh, I understand. Fair enough. But -1 is null, so 5 next is null. So let's do one thing. Can we say past is not equal to past of, wait, I mean, I understand what's happening, I guess. Thing is that it starts from here. Past is at 17, it's at 10. Past is at 4, then past is at 5, then past is at 33, 16, 12, -12, 29, 5, 20, 14, 13, 21, 25, I mean -21, null. Slow dot next also, at some point we'll get null. It's gonna get equal, so it's gonna be like, alright, let's return true. I understand that thing. I understand. So I can have a null, but null check for what? I can say if past is not equal to null and not gonna work. Not bad. A very dumb thing that I'm doing. Thing is that if fast gets equal to slow, fast not null, faster next not null, keep moving fast ahead, keep moving slow ahead. The moment fast gets equal to slow, return true, else you return false. Oh, it works. Let's see for the others. accept it. I understand that. I mean, can I remove a few of these things? Will it working? Yeah, it would. Of course it would. If I remove this too, will it work? Yeah, makes sense. Cool. So the thing that was happening is I was trying all these stupid edge cases. The basic is like all I have to do is make sure that fast is not null and fast dot next is not null. That's it. Because the thing is, if fast is null, I won't be able to move ahead, of course. Or worst case that was happening was fast became equal to null and slow became equal to null, and my while loop was like till the moment fast and slow are not equal. So fast became null, slow became null. It was not caring about whatever is gonna happen next. It was like, alright, fast is null, slow is null, return. Like, return true, because they are equal. So I don't want that. I'm like, oh yeah, so I'm like, yeah, fast is not null and fast dot next is not null. So due to which the thing is I will be easily able to figure out what fast is gonna do, because fast is eventually gonna go fast dot next dot next. So if fast is null, it stops. If fast dot next is null, it also stops, because yeah, if fast dot next gets equals to null, then fast becomes null eventually, and yeah, then slow becomes whatever the slow becomes. The moment the loop is gonna get executed again, because this is not gonna happen, of course, if slow doesn't become null. The thing is, the loop is gonna get executed again, and it's gonna be like fast is null, alright, ended, return false, fast became null. So I had to take care wherein there was no cycle. That means I had to take care wherein the loop was actually ending. When will the thing end? And not meaning that the loop was actually ending. What I mean is when the cycle was actually ending. The cycle will end when something becomes equals to null. So yeah, the chances of fast becoming null are first. Like first of all, out of slow and fast is gonna get null. So the moment we see fast getting null or fast dot next getting null, yeah, we stop the loop. We return a false because we got the endpoint. In a cycle, there is no null point. That is the basic understanding that had to be understood way before. It came late, but yeah, the basic understanding is in a cycle you can't have anything as null. That's the basic understanding. If there is a cycle, there won't be anything dot next as null. So if anything dot next is at null, yeah, that's not a cycle. So yeah, can I have like the check for like if fast or next is null? Will it work? Yeah, of course it would. Yeah. Yeah, the thing is I can keep going ahead with the whole null thing. The thing is, just have to make sure that how about oh my god, what if I do this? Yeah, and that is the reason you should have a fast thing and a null thing. That's it. No, like yeah, this is enough. The reason is, what if my fast was not null, so I moved ahead. Now my fast pointer is like, cool, fast dot next is null. For example, uh, What can be the right example for the way it didn't work? Why? Like, not next. For that, my fast has to be null. Yeah. So my fast, like, becomes null. Yeah. Hmm. Won't my loop end the moment fast gets to null? I'm like, alright, my fast is now null. So I mean, I understand the check fast dot next because anything null can't be having a next to attached to it. Like null dot next is gonna give an error. So yeah. But the thing is, if it's null, it's ending either way. So, like for example, here, if the cycle would have ended, the fast would have been at this place, and it would have checked is fast null, no, and is fast or next null, no. Cool. Let's do it. Fast then would have been null because next or next. It would have checked if fast is null. Right, it's null. End it. Why do I need this thing? Wait, let's rectify it. Why do I need to have a check for fast dot next not equal null? I mean, it would stop if fast became null. Oh, fair enough. Understood. Yeah. So, if fast was right here, fast dot next, is it null? No. So, like, if fast is right here after the first iteration, is fast null? No. Fast dot next null? No. So you can move ahead. Then fast is gonna be null, so it stops if there was no cycle. Thing is, if fast was right here, is fast null? No. It would have moved ahead if this thing wouldn't have been the case. And if it would have moved ahead, fast dot next would have been null. Alright, fast is now null. The thing would have been, if fast is now set as null, dot next would have been like null dot next because this thing would have been null. So anything such as null dot next would throw an exception like this. Another pointed exception. So cool. Understood. Why do we need that? It's fine. Yeah. Makes sense. All you need is 2. Alright.